So I'm Keagan, for those of you guys who don't know me. I just love data, that's why I'm here. Yeah, pretty much. So, hold on. You gonna start?
Sure.
Okay. So today we're gonna talk about audio data. I know there's some people out here who work with audio data for their job, so they're way more qualified to talk about it than me, but here I am, giving it a go. So audio recognition, right? And so I went through, like Matt said, a few different solutions. People released documentation after the release, but if you remember one thing before you leave here, remember this. If there's some techniques, right? There's one technique. Maybe we're going to talk about it today. Maybe you're going to read about it on the bus when you go home. But there's a technique that you can use to improve your Kaggle submission, and maybe no one in that competition has thought of it yet, right? So that could be lurking anywhere, right? That winning edge. So I don't consider myself an expert on audio data, right? After one competition. However, I did learn various things from some really smart people at Kaggle. And this presentation kind of relies on all their hard work and all the documentation. So this competition was my first ever competition. And I'm super excited about how I did in the competition. 147th on my first crack at it, right? Not bad. So today I'm just going to go through some of the winners' techniques, some of the really clever things that they've done that really stood out to me. And I tried to pick ones that would apply to any Kaggle competition, not just maybe audio data, although there is one that's just for audio, but anyway. If you want to make a comment or question or whatever, don't hesitate to interrupt or just throw your hand up and we'll get that mic over to you. So when most people think about audio recognition, they think about Google, maybe Google Translate. Like Google Translate can pretty much translate any audio information you give it. If you say like, parlez-vous baguette, you might get like a translation in perfect German, like, wie, ich bin eine Bratwurst, or whatever, right? But not all auditory information, not all sounds can be interpreted in terms of language, or with language models, sorry. So it's important to appreciate the ambient information, the ambient sound information, right? So this was the timeline pretty much. Daisuke Lab is, turn my head over there. Daisuke Lab was the guy who won the Citizenship Award, or rather the Judges Award, for releasing all his kernels and just helping out the community in that sense. He did a lot of pre-processing for everyone, that a lot of the heavy lifting that everyone kind of relied on. So I just want to give him a shout out. So contrary to last year's competition,
Can I
do a question? Yeah.
What sort of prize does he win for that?
I think it was $800.
Oh, okay, that's cool.
Yeah. All the other ones were first, second, third was in the thousands for sure. Yeah. So contrary to last year, which is also on the spreadsheet, on the Meetup spreadsheet or whatever, there was another presentation about it. But the key difference is, I'm just going to highlight here, there's more than one label per audio clip, right? So they had to change the evaluation metric to suit that there are more than one label per audio clip. And basically, it's a ranking system. So like, if you want to read here, I don't know. It'll basically rank according to the labels instead of according to the audio clips, or it doesn't discount the labels if there are multiple on one audio clip, right? Okay, lol wrap. Sampling rate. Old news.
Sorry, can we spend a little bit of time on how the loss is? Like, actually, if you could read that would be, I think that would be.
Read that?
No, not that. On the I don't know where it went.
Where were we? Sorry, here?
Before this?
Right.
Yes, this one.
Okay. Yeah. Label weighted, label ranking, average precision. Yeah, they just made it up, right? It's an evaluation metric. They totally made it up. Yeah, if you have any questions.
I mean, can you give us some maybe perspective or like some reason why they would do that, I guess?
I mean, to mess with us? I don't know. Yeah, I couldn't really give you an insight on it. It's just you submit your...
Like if there are multiple labels,
Yeah.
is it like if there are like the same label but it appears multiple times, then it get a higher weight? Is it what it is?
Yeah, so that's how it would be in the LRAP, right? But it would... So if you applied multiple labels to it, you don't want it to be discounted, right? And that's kind of what this fixes, right? Like if you applied, if you sorted by the audio clip, then, yeah. Sorry, I'm being put on the...
Can you go back to the slide where it showed that sound shapes and you said what they translate to?
We're here?
No, actually way before, yeah.
I don't think I...
Before. Up.
Did I?
No, before all of this. Like it was way in the beginning. It was maybe
Like nothing to see here, or?
it was like right after that. Maybe slide number 3.
That? Oh, this, yeah.
Yeah. Okay. So basically, you are saying that because each of these sound samples have multiple labels, is that the reason you're using it?
Yeah.
Okay. So what happens, for example, if in the third one, instead of his, I get one wrong? It's going to...
Well, it's a ranking, like, so based on how confident you are that it's a earthquake or whatever, you might put earthquake as a higher number, right? Like, so, yeah.
Okay.
Just, yeah.
These are not ordered, right? These are just like the labels you give to each sound sample.
Sorry?
In terms of the data that they have given you, there is no priority to each of these samples, right?
Yeah, so let me clarify. So yeah, we get a ground truth labels for each audio clip, and an audio clip may have one label or it may have several labels, right? And we'll look at that.
Okay.
Yeah.
Still on that side. Okay, I think I'm getting it. So when you submit your solution,
Yeah.
what are you submitting?
It's like a one hot e to the negative whatever. One hot.
So you're submitting probability, pseudo probability things for each prediction. Okay, so where does the ranking come in?
I guess it's the order of how high the number is.
Okay, so they'll like order your most likely sound, and then your second most likely and third most likely. And if you get one of
for each label, yeah.
And if you get one of the, like, if it was like your fifth most likely that is wrong, all of a sudden you're not punished as much as if it's your first most likely that's wrong.
Yeah.
Okay. Okay, I think
Okay, we good? Okay. Yeah. So contrary to last year, one of the new additions, which I thought was really interesting, was the curated versus noisy set. So the curated set is hand labeled and human verified, and the noisy set is machine predicted, right? Predicted by Freesound, and obviously it's going to be less accurate. But I thought that was a really interesting addition, right? And the winners have dealt with it in various ways. Some really clever ways like warm up. So using the noisy set to kind of get features before you...
Can we just dwell a little more on this?
Yeah.
So in particular, what you're saying here is that of the 80 labels, there are 5 that no human has ever labeled.
Oh, so
They're
yeah.
only available
yeah.
in the noisy set. Is that what
Yeah,
I'm reading?
good catch there. Yeah, I sort of glossed over that. They didn't put 5 of the labels in the curated set. So it kind of incentivizes you to use the noisy set, which I think is a really good idea. Forces people to think. Yeah.
And do they just state that 65% accuracy? Like they just told you that? Because I guess we don't know, do we?
I mean, that's the accuracy that I got when I trained a model on it, on the noisy set. So,
Oh, I see.
yeah.
Okay.
Yes. Yeah, so warm up, training the model on the noisy set to get some features, and then polishing it off with the curated set. Kind of makes sense, right? And then this one I thought was super clever. I wish I'd thought of it. Pseudo-labeling. I don't know if it's a common thing Matt thinks it is, but yeah, so what they did was train a model on the curated set first, and then use that to predict on the noisy set. And like, you got the best audio files from there and pulled them into the curated set, added them to the curated set. I thought it was pretty cool. It would have been easy to implement too.
Sorry, we're getting a little feedback. Are both microphones on mute? Sometimes when the hand mics are on, it gets sort of it's on mute? Yeah? Okay, thanks.
Okay.
Something else.
Okay. Oh, question, yeah. But, yeah.
The light should be green.
Hello? About the noise sample, was it randomly chosen sample, or was it the same group of noise sample? How was a noise sample selected?
You mean for the pseudo labeling?
Yes. I mean, was it each noise sample, was it different from another one, or was there like a group of noise sample that was, or was it categorized categorized into different type of noise sample and then label it, or is each labeled noise sample is different from another noise sample? How was it chosen?
So what this guy did was trained a model on the curated set first, and then used the best performing or the best audio files from the noisy set and brought them into the curated set. Does that answer your question?
Maybe a related question would be like, so the noisy data is like badly labeled,
Yeah.
not noisy audio.
Noisy labels.
Noisy label, not noisy audio. So that's maybe
key.
part
That's
of it.
key. Yeah,
so
thanks
if
a
I
lot.
listened, it would sound like normal sound.
It's normal sound.
Yeah. Okay.
Yeah. The audio clips sound exactly the same. It's just the labels are noisy. Yeah. Good catch there. Yeah. Thanks, Lexi.
Noisy is very confusing here. Can you go back one more slide? Do you have, like, so they told you what was noisy and they told you what was curated.
Yeah. They're in different folders.
And how, was it like the same size of the, like?
No. Sorry, I forgot to mention this as well. The split was 80-20. So 20% curated and 80% noisy. Yeah. So 80% noisy, yeah.
You mentioned unbalanced classes. Can you, like, how unbalanced would you say?
For the curated set, not as much, but it's not really an issue. As far as some other winners have said, it wasn't a big issue for them because of the way the evaluation metric is calculated. I'm not really sure if that's correct, but that's what they said.
So I guess I had one thing to say. If you go forward a slide on the pseudo labeling slide. Yeah. So as you were saying this, I was going like, yes, nodding my head because I've seen the term used before. But actually, the way I've seen it used is different than this. And so pseudo labeling, from my perspective before, was when you have unlabeled data that you want to use for training, is you can take a model on all of your labeled data. You can see which records in your unlabeled data you're not sure about, and then you can re-enter those into your labeled data.
Okay.
And I've seen several cases where that's helped people in Kaggle competitions, and several times where people say, this doesn't make any sense and it doesn't help. So I'm not sure. I feel a little bit iffy about that, but I just thought I'd clarify that this is actually something a little bit different.
Yeah. Thanks for that, Matt. And the other Matt in the back.
Do you know if the test data set was mostly from the noisy or from the curated data set?
The test data set was hand labeled.
Okay, so all curated then?
Yeah, but we were not allowed to use the test set to train. Yeah.
Yeah, makes sense.
Yeah. Okay. Okay, I just want to get a quick show of hands here. How many of you guys have used Mixup in a past competition or in work or whatever? Okay. How many of you guys have heard of it and vaguely remember reading it on the bus late at night and falling asleep and you don't want to be asked to remember specific details? Okay.
We did it in the reading group.
Yeah. So I was about to say, yeah, Alexi did. Didn't you nominate it, Alexi? Yeah. So Alexi nominated this paper, Beyond Empirical Risk Management. Yeah, it was a good paper. I remember Bruce's feelings at the time were kind of, I have my doubts, and I'll believe it when I see it. Yeah. Does that sound about right?
That's about right.
Is that a fair characterization? Mm-hmm. Okay, thank you. So yeah, this was originally made for image recognition or whatever. This mix-up thing. So what it does is it creates a new sample, a new training sample, based on combining some existing training samples. And so creates a new training sample based on a weighted average of 2 items from the original data set. So yeah, is this a dog or a cat?
Dog.
Okay, you're mostly right. It's 70% dog, 30% cat. Okay. So, yeah. So for audio data, though, people had to change their approach because you can't exactly overlay an audio clip. Like the way we did our pre-processing, we made spectrograms, right? And when you overlay something like this, it'll change the information, right? And so you have to be careful when you're doing your data augmentation. Like if you flip it or you rotate it the wrong way, it'll sound completely different, right? So, so some people came up with some really clever ways to actually implement this in their solutions. Yeah. So
Before a couple of questions. Armin, you go first.
Yeah, sorry, because I'm not familiar with Mixup. Can I tell you what I understood from what you said?
Yeah.
I think you were saying that if you, for example, have photos of cats and dogs, and you have a one hot encoded that is like a cat 1, dog 1, you create these mix-up images that is like cat 0.3, dog 0.7.
Yeah.
And then you okay.
Yeah, so it presents the model with an example that is, in a way that is amenable to learning, right?
Okay.
Yeah.
I might reveal some profound ignorance about audio here, but I'd be curious to know, so if I combined two audio signals in the time domain just by mixing them with some alpha, is it the same, if I do the spectrograms, would it be the same as adding them? Okay.
Going to spectrogram is a linear operation, so the spectrogram of the sum is the sum of spectrograms.
Okay.
Yeah. So if you just add them up, sorry, I don't have a mic. If you just add them up, it's just you'll just hear 2 sounds at once. It won't sound particularly weird. It won't look like a weird cat-dog thing. It'll just sound like you're hearing 2 sounds at once. But I guess they didn't want to do that because the labels, I don't know why they didn't want to do that.
Yeah, I beg to differ on that because when you look at the actual results that they got from using Mixup, the first place guy, what he actually did was use a transition. So he used a sigmoid concat mixer, right? And you can actually kind of see here which ones are transitioned. Like say, for example, this one has kind of a smooth transition here, like maybe 70% earthquake, 30% waterfall or something like that. And a few of these. There's some more augmentation here that you see that we're going to get to. Yeah.
So the labels for these sound clips are multi-labels, right? So if you kind of combine two different sound clips, are you just saying, okay, now this is just both of these sounds?
I guess. Yeah, I guess so. I haven't really thought about that. Multi-label, you'd have to, yeah. I guess the percentages would be different then.
Well, I mean, I guess it's a question of whether the sounds that, say you've got two sounds, two labels.
Yeah.
Do those sounds occur at the same time and they're overlapping each other, or they occur at different times? If they're occurring at the same time, then this business of just adding up the spectrograms would be fine. You'll get a signal where two sounds are happening at the same time. What the technique that you described is starting with a sound at the beginning of the file and ending up with a different sound at the end of the file. So they're doing it, the merge happens over the time axis rather than over the amplitude axis, which...
You could do it either way, I'm sure.
I don't know. But so when you listen, I assume you listen to a bunch of these files, and ones with multiple labels, were the sounds occurring at the same time, or were they one after the other?
They were one after the other.
They were one after the other. Okay, in that case, this procedure makes perfect sense, and just adding them up would be, well, it'd be like the dog versus, or dog plus cat thing, which...
But the multi-label part of it, is that not that? You wouldn't use ratios anymore for your labels. You would just say that this clip now has two different labels, like bold ones.
Yeah, but your confidence in the labels might be, and the number of labels is not perfect, so you're going to give a probability.
Why wouldn't you be confident? Oh.
Because it's machine learning. You're not confident of anything.
Can I ask, just because we're getting into a little bit some intuition related to the data.
Yeah.
So is earthquake a label?
No.
Okay, is waterfall a label? Like I know there's 80, but like what are like 8 random labels off the top
I
of
don't
your
know,
head?
toilet flushing, dog barking, man singing, woman crying. Like,
Okay.
Yeah,
That kind of thing. Okay.
There's no earthquake. Yeah. Yeah.
Hi. I'm curious if these labels, so if you have sound clips and you have 3 labels for it, what's stopping people from, and these sounds come one after another, why wouldn't you just chop these sound clips up and create more sound clips with more labels and just make save yourself the headache of multi-label and just play in the single label?
That's one way you could do it. I'm not sure how it would work out with once you train the model, whether it would assign multiple labels.
I mean,
Maybe.
you can maybe train something to learn where to segment the audio clips as well, so that...
Yeah. So we'll get to that later too, and different approaches to that. Because a lot of the audio clips, I'll get to it later.
Sorry, one small question. So
Yeah.
the labels are not together. So for example, when we were saying man crying, it's not man one label crying the other.
No.
It's like man crying.
Yeah, it's one label, yeah.
Okay.
Man crying, yeah.
Actually, would it be possible to hear some of these sound clips? Like
Yeah, we'll get to it. We'll get to it.
we'll get to that.
Yeah. And the other augmentation you see is the SpecAugment, right? And this is only for use with audio data, but pretty much, I'm gonna let this simmer actually. I'll let you guys, I'm gonna get a sip here. Question in the back?
What's WER?
I have no idea. We're not going to get into that.
Word error rate?
Why is it called SpecAugment? It's not obvious to me.
Because this is called spectrograms, these things. Yeah. So just a visual representation of the different transformations you do, or the masks you apply, I guess. Yeah. So, yeah.
These are spectrograms. I know there are many people who are well versed in audio in the room. These are histograms of frequencies over time or something? Or what's a spectrogram definition?
So you're looking at time on the X, frequency on the Y, and then I think the brightness is like amplitude, right? Yeah. That's it. That's it. Sorry, do you need a microphone back?
Yeah, that's right.
Yeah, Fourier transform, that's it.
You basically do the Fourier transform over little frames along the time axis. Yeah, you've got a window, and then you take the Fourier transform. That gives you the frequencies at that window. You just do that all the way along the x-axis, so you see how the frequencies are changing through time.
Yeah. Yeah.
If the audio file, the time would be different. For example, 25 seconds for man crying, and let's say 5 seconds for another. What do you do with spectrogram?
Yeah, so we'll get into that later too, but pretty much some different approaches where either you can feed the model little tiny windows, little tiny slices of each audio clip, or you can repeat the short audio clips and just have one big, make them all the same, like that way, yeah. Thank you, what was your name? Midal, thanks Midal, yeah. Yeah. So this guy used a kernel for his first place solution. Heresy. Yeah. Or at least he incorporated that model into his final solution. Yeah. Yeah.
Is he using convolutional or is it MLP?
He used a bunch of different things. Yeah, he used convolutional. Yeah. So, yeah, SpecAugment, Mixup, we already saw that. Hand relabeling, so a lot of these guys in the top 5 range did a lot of hand relabeling. I know Alexi's got his head in his hands right now. Yeah, no, that's not the way to go. But anyways.
Just a question. Do you know what they mean by auxiliary classifiers?
Auxiliary classifiers? No? No. Do you? Care to elaborate? Anyone?
I could guess. I mean, like, I was just getting myself into some image segmentation stuff, and you like a traditional neural network might just feed forward all the way to the end, and then you might classify. But you might be tempted to hang classifiers off at like midpoints in your network, where presumably like the features aren't as good, but it allows you to like it's like hand waving very much now, like kind of inject signal and perhaps get around vanishing gradients because you're again like injecting gradients kind of midway through your network. So that's probably what that is.
That's absolutely right. Thanks, Alexi. Yeah, variable length. Let's look at. We got time. Let's look at this.
Oh, did anyone do time domain solutions, or is it all spectrograms?
Yeah, not that I've seen. How's it going? There. Okay. This is gonna be the most boring audio clip you'll ever hear. I don't know if you'll be able to hear it though.
Let us guess what the sound is.
Is there? Oh shoot, we forgot to test the sound. It's okay, it's super boring. Yeah.
We can do it. We've done it before. Can we? Is your laptop on?
Bruce?
Oh, was it coming out there?
Can you hear it? Okay. So that's this one. It's just traffic, ambient traffic. Right, so those are two different lengths. So you'd have to repeat the horn honking there a few more times, maybe 15 times to get the same length. But this is the distribution of the different lengths. So this is 1 second right here. I think it is. Is that 500,000? Yeah. So yeah, some of them are pretty long. Some of them are longer than this frame. But yeah.
The x-axis is units of audio samples?
Yeah, it's histogram. Yeah.
No, but the x-axis, those are units of audio samples? Or
Yes.
not
samples.
seconds?
They're samples, yeah.
So you have a huge number of things with just like
With just
10
really short.
samples?
Well, somewhere around there, yeah.
Yeah, okay. Do you know what the sampling rate was? 8 kilohertz?
44.1 kilohertz.
44.1, okay. A lot of extremely short files here.
Yeah.
And then there is one that is very, very long, right? That
Yeah.
very end.
Yeah, this window is actually trimmed, but yeah, there's a few more that are longer. Yeah. Yeah, and then we can cut them into little pieces like that. These are all the same audio clip, it's just in different, at different periods. And then this is a log mail spectrogram, which is the same audio clip as this actually, which might be fun to look at in 3D. Woohoo! No. Where do we go now? Okay, let's go back to the slides. We've had our fun. Okay. Yeah, so like I said before, they maybe repeated the shorter clips. That's what the first place guy did, at least. Makes sense with his implementation of Mixup, right? So I kind of want to ask the group this. How many of you guys think you need to know less than 10 papers to win a medal in Kaggle? Okay, more than 10 papers? Okay. Okay. All right. But yeah, some of these competition winners put a lot of time into hand relabeling, which I don't know about that. Anyways, Matt?
So I don't know of any competitions before this one where that was actually a strategy, and I thought that was against the rules of Kaggle.
It is against the rules, but it's not against the rules unless you're relabeling the test set, as far as I understand. So you're not allowed to relabel the test set, but the training set, you can.
Well, you don't have any labels for the test set, so there is no relabeling of the test set.
There's an offline test set that you can use to test. You just can't train with it, that's all.
I think of other competitions, they deliberately give them this noisy things and told us that they were noisy.
Yeah, it's kind of a new thing.
Fix up noisy labels all the time, actually.
Oh, actually,
They're accidentally noisy.
yeah. Okay, I remember that.
Yeah.
Were there people sharing a lot of fixes in the forums about?
Not that I had seen, no. People kept that to themselves, I think. Yeah. 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 So, yeah, over here.
Now it's green.
Okay.
Okay, so this is actually from a couple slides ago, but you mentioned that some people, like, could you just help me understand, like, how you're using the input data? So you've obviously got, like, frequency, time, amplitude, or whatever.
Yeah.
But you said people, like, use the spectrographs to, like,
Yeah,
how are you using that? Like, you're not...
Yeah.
Are you using the image data somehow, or?
So
I don't quite
I
get that.
kind of forgot to mention that we're getting pretty much raw wave files, right? Are you familiar with the wave file?
Yeah.
Yeah, so we use those wave files to transform them into images because there are more powerful image models out there. Yeah.
Oh, okay. So you're actually using the image data once it's
Yeah.
transformed.
Yeah.
Okay. Cool. Thanks.
Another question?
Which deep learning platform did you use? TensorFlow or PyTorch or Keras?
I recently did a new one. I did the Fast AI course,
Okay.
which was really fun.
Basically, it's PyTorch, right?
Yeah, it's PyTorch. Yeah.
Actually, I have a kind of curious question about that.
Yeah.
So FastAI, they've tried to release their own library in part of their course, right?
Yeah.
That's kind of based on PyTorch. Do people use the FastAI library? Has that like taken? Does anybody here use the FastAI library for deep learning? How is it going, Trevor? Okay.
Yeah, on Kaggle it's pretty unstable because yeah. The support is not too great for it on Kaggle just yet, but hopefully that'll change. Yeah, and yeah, pretty much out of respect for your guys' time, I know we're just about at 7:30 here, so I'm gonna finish there. And yeah, thank you guys. Thank you guys for listening. Hopefully you got something out of it.
Well, we have time for questions if anybody.
Yeah, any final questions? If you guys, yeah.
Can we go back to the slide showing the model architecture?
Yeah, this one?
Yeah. Can you maybe elaborate a little bit more about the additions, the changes that he made? Like the attention, skip connections?
I'm not an expert on attention. Maybe I'll throw that back to the room to see if anyone else is. Matt, maybe you want to answer it, or? Yeah. Okay.
Hey, yeah, so the idea of attention is that, so this is trying to get around some of the difficulties, especially of like RNNs. There was like a big paper that came out called Attention is All That You Need. And the idea was that as you're going through trying to, like with some sort of sequence, in this case we have like sound, you actually want the model itself to start labeling what it thinks are the most important bits. So my understanding of it comes from like NLP, where, you know, depending on like the sentence structure, like I really hate it when you something, right? That really is starting to like influence other parts of it. So it actually would make sense to kind of go back further in time and take a look at this, that really, or that hate, right? Because that's such a strong negative word. And I'm trying to remember exactly how this is implemented, but it's actually like a pretty simple architectural tweak where, yeah, you put weights on the amount that you care about each input that comes before this input that you're trying to go with, and that you learn that over time. Does anyone else want to take a better crack at that? But that's like the 10,000 feet in the air kind of version.
Awesome. Thanks, Matt. Okay.
If I may, let's do it.
Maybe I'll just do a very high level. Okay. It's Matt versus Matt here. Yeah, so in NLP, because that's my perspective as well, I like the comparison of typical RNNs and kind of the new way of doing things. So networks that take advantage of attention now are called transformer networks, and there's like self-attention, but then there was also this attention thing in translations. But I guess the overall idea is that as you're processing each time step, you're looking at that one piece of data that comes in at that time step, but you also want to pay attention to the other pieces of data across the full data, like across all of your, like across that whole record. And so attention is a way of saying, okay, well, here's my input at this time, but I also want to kind of look at all the other data and see how much it matches up in this kind of, in this learned way, and then also add in those signals into my current time step. That's kind of how it's used in NLP, because like your example, really, so the word really does, you need the context to understand what that word is really meaning. So when you process really, it would look at all of the other words, and it looks at learned matrices to say, well, how much does the word really pay attention, like how much does that word pay attention to other words in your sentence? And then so it would add in, so if really and hate kind of like are similar in that sort of way, then it would add a lot of that information of hate into your word really, and then that would kind of be how you would represent that part of the sentence. So that's called self-attention.
Yeah.
I have no idea how it's used in this case. But I would like you to go back to the network though.
Okay.
Did that help at all, or does anybody have another
Can
way to
we
describe
say
this?
attention is weighted RNN?
Well, actually, transformers are not RNNs at all. So you kind of remove that way of modeling sequences. You can model in a transformer network. You can do everything in parallel. That's one of the big advantages over RNNs. Is RNNs you have to know the previous word to like process your next word. And when you're predicting using transformers, that same constraint is. But when you're learning, if you have the full sentence already and you're trying to classify it or something, you can do every word at the same time, because every word pays attention to all the other words. So you can do those all in parallel.
Great. Okay.
But yeah, I do want to stay on this. So I don't know how attention is used here. It's probably a word that should have many different words to describe what it is, because self-attention and other attention are similar only in some ways. Actually, I wanted to ask you what your solution was, because you did very well. And maybe you can speak a little bit
that sounds
about
like a
that.
beer question. Okay, I think we're at time now, so
no.
I will direct all further questions to my beer at Rogue. I'll direct the further questions to my beer. Thank you.
Okay.
All right. Thank you guys for listening. Hope you got something out of it. Yeah.
Well, hold off on that round of applause, because I was just going to do my thing, and then.
Okay.
Round of applause, because it's the end of the video, right?
Yeah.